Hi everyone. In this video, we're going to go over a handout. You can find this handout on modules under study guides. So it'll be the last file under study guides this week. And let's just pull up this file and go over it. So far we've been talking about nucleophiles, and we've said that they're essentially bases because they have a lone pair to donate. However, nucleophiles and bases do have some differences, so let's go over those. And the reason we want to understand the difference between nucleophiles and bases is because this will help us in the future determine whether a reaction will undergo substitution or elimination. So let's start by going over the main difference between bases and nucleophiles. So Bronsted-Lowry bases involve, or basicity involves attack on a proton. However, nucleophilicity involves attack on a non-hydrogen atom such as carbon. So down below you can see that our base and our nucleophile look pretty similar. They both have a lone pair and they have a negative charge. However, bases are going to grab onto a proton, whereas nucleophiles are going to attack a non-hydrogen atom, such as carbon. And it will most often be carbon. Now, in both scenarios, we have a leaving group that leaves, and it becomes negatively charged. However, in the first reaction with our base, we really have an acid-base reaction, right? So in the products, we have our conjugate acid, which is the base bonded to a hydrogen, and our conjugate base, which is the leaving group, and now it has a negative charge. But if we look at our nucleophile reaction, it attacks the carbon and the leaving group leaves, and we end up with our two new products. So that is not an acid-base reaction, that is a substitution reaction, for instance. Now, there's another difference between bases and nucleophiles, and that has to do with kinetics versus thermodynamics. So remember, kinetics is all about the rate of a reaction, whereas thermodynamics is more about the stability of your products. So an important difference between nucleophilicity and basicity is nucleophilicity is a measure of kinetics. So how quickly does a reaction occur? So for instance, if you're comparing to nucleophiles, you're really thinking about how quickly the reaction occurs. But with basicity, that's a measure of thermodynamics. So how stable are your products or even the reactants? So when you're comparing bases, you're more concerned with how stable the products are. Or actually, another way to think about it is how stable your equilibrium is, because sometimes we have a back and forth between the reactants and the products. So let's look at nucleophilicity to start. So better nucleophiles react more quickly than less nucleophilic reagents. So looking down below at our reaction coordinate diagram, this is a hypothetical situation where we have two different reactions. One is in blue and one is in red. The blue reaction is a slower reaction because we have a greater energy of activation, activation energy, versus the red line, which has a smaller activation energy. So the activation energy of the blue curve is much greater than the activation energy of the red curve. So again, the blue curve represents a slower reaction, and the rate of that reaction is small. So remember, you can use this value K to indicate the rate of a reaction. And then the red curve symbolizes a faster reaction because the activation energy is quite low. So the reactants can very easily get over that barrier and produce products. So up above, better nucleophiles again give faster reactions, which is indicated by a lower transition state energy or activation energy and a larger rate constant. And then worse nucleophiles give slower reactions, which is indicated by a higher transition state energy or higher activation energy and a smaller rate constant. Okay, so that's just a hypothetical, but again, just remember those trends. If you have a good nucleophile, you should have a faster reaction with a lower activation energy and a larger rate constant. But if you don't have a very good nucleophile, then your reaction will be slower. You'll have a larger activation energy and a smaller rate constant. All right, so again, nucleophilicity has to do with rates of reaction, kinetics. So let's look at basicity. So when we're considering bases, again, we're more concerned with the stability of our reactants and products. So that could just be the stability of the products, or that could be the equilibrium state. So how stable is equilibrium? So better bases make products that are thermodynamically more stable than those formed by weak bases. So let's look at our hypothetical reaction coordinate diagram down below. Now the reactants are both at the same energy levels for these two different scenarios, so we can kind of eliminate that as a factor in our discussion. We can also see that the activation energies are the same for these two reactions. The only difference is the energy of the products. So we have our blue products, which are higher in energy, and our red products, which are lower in energy. And remember, if something is higher in energy, it's more unstable. Whereas if something's lower in energy, that is more stable. And I don't know if I've used this analogy before, but sometimes I think about when you give little kids sugar. They have a bunch of energy and they're running around, and you know they're not staying still. They're really unstable and jumping around. Whereas if you don't give a kid sugar, they'll hopefully be a little less energetic. So I kind of like to think about it that way sometimes. Okay, so better bases favor products more at equilibrium or more stable. And that is due to the fact that the change in energy between the reactants and products is larger or more negative. Now, worse bases favor products less at equilibrium or less stable because that change in energy is actually smaller or less negative. So again, when we're considering bases, we're really thinking about the stability of our products or how stable is our equilibrium state. So better bases favor more stable products or products that are more at equilibrium. whereas worse bases favor products that are higher in energy or less at equilibrium. Okay, so these are just a few of the differences between nucleophiles and bases. And again, you can print out this handout or even, just save it to your device to go over. Now, one other thing that's on this handout are some trends, but we'll go over that in the next video because that's going to involve a larger discussion. We're going to have to talk about solvents in addition to stability of a nucleophile or a base. So I will see you in the next video.